Hi and welcome to this Now Maths video on factorising the difference of two squares. Before we get started, we need to know what actually is factorising. Well, factorising is where we use factors in order to put an algebraic expression into a bracket or brackets. We also need to know what we mean by the difference of two squares. Well, the difference of two squares looks something like what's on screen now. It's a combination of two terms which are both squared, and the difference part comes from the fact that they are being subtracted. In this video, we're going to focus on how to factorise expressions that are in this form. So let's take a look at some examples. So first of all, let's take a look at the question on the left. We can tell that this is a difference of two squares because each term is a square number, 25 is 5 squared, and the subtraction makes it a difference. Now if we were to try and factorise this into a single bracket, we would need to find a factor of each term that we could pull to the front of that single bracket. There is no factor greater than 1 which goes into each of these terms, so that tells us that we need to actually factorise this into double brackets rather than single. Now to factorise the difference of two squares, we're going to use square roots to help us. So looking at the x squared term first, the square root of x squared is x, so we're going to put x in the front of each bracket. Then we're going to look at the 25, and the square root of 25 is 5, so we're going to put a 5 in the end of each bracket. Given that when we expand these brackets out, the two 5s need to multiply to give negative 25, one of the 5s will have to be positive and the other will have to be negative. This is our fully factorised answer, but just to double check that this actually works, we're going to expand the double brackets out and check we get what we started with. So starting off with x multiplied by x, we get x squared. Then x multiplied by negative 5 is negative 5x. Then positive 5 multiplied by x is plus 5x, and positive 5 multiplied by negative 5 is negative 25. And if we simplify this, we have a negative 5x and a positive 5x, which simplify to give us 0. So we get x squared, subtract 25 when we simplify, and this is exactly what we started with, so we must have factorised our quadratic correctly. Now looking at the question on the right hand side, we're going to use the exact same method to factorise this, and we know we're going to factorise this into double brackets since there are no common factors in each term that are greater than 1. Now using square roots to help us, the square root of a squared is a, so we put that in the front of each bracket. Then the square root of 16 is 4. And given that we need the two 4s to multiply to give negative 16, we need one of them to be positive and the other to be negative. And this is our fully factorised quadratic. And it is worth noting that on either of these questions, if the brackets were written in the opposite order, this would still be a fully correct factorisation since multiplication is commutative, so it doesn't matter which order we do it in. Now let's have a look at a couple of more complex questions. So looking at the question on the left first, this is going to factorise into double brackets again, and that's because if we look at each term, there is no factor greater than 1 that goes into each. This is definitely a difference of two squares, since 4x squared is 2x multiplied by 2x, and 9 is 3 multiplied by 3, and it's a difference because of the subtraction. We're now going to use square roots to help us. So the square root of 4x squared is 2x, since 2x multiplied by 2x is 4x squared. Then the square root of 9 is 3. And given that we need the two 3s to multiply to give negative 9, we need one of them to be positive and the other to be negative. And this is our fully factorised difference of two squares. And similar to the previous question, we could have these brackets written in the opposite order. Now let's take a look at the question on the right hand side. Again, this is going to go into double brackets since there are no numbers greater than 1 that go into each of our terms. And it's a difference of two squares since we have two squared terms and a subtraction in the middle. Now using square roots to help us, the square root of 25y squared is 5y, since 5y multiplied by 5y gives us 25y squared. Then the square root of 121 is 11, since 11 multiplied by 11 is 121. And given that we need the 11s to multiply to give negative 121, we need one of them to be positive and the other to be negative. And this is our fully factorised difference of two squares. and again the brackets could be written in either order. Now let's take a look at our most complex type of question to answer. So looking at the question on the left first, similar to previously, this is going to factorise into double brackets since there are no numbers greater than 1 which go into each of our terms. And we know we're looking at a difference of 2 squares since both terms are square and the subtraction makes it a difference. Now using square roots to help us, the square root of 4x squared is 2x since 2x multiplied by 2x is 4x squared. Then the square root of 9y squared is 3y, since 3y multiplied by 3y is 9y squared. And given that we need the 3y's to multiply to give negative 9y squared, we need one of them to be positive and the other to be negative. And this is our fully factorised difference of 2 squares. And once again, the brackets could be written in either order. Now for our final question, again we're going to factorise this into double brackets since there are no factors greater than 1 in each of our terms. We know we're looking at a difference of 2 squares since each term is a square number and it's a difference because of the subtraction. And again we're going to use square roots to help us factorise here. So the square root of 100a squared is 10a since 10a multiplied by 10a is 100a squared. Then the square root of 49b squared is 7b, since 7b multiplied by 7b is 49b squared. And given that we need our 7b's to multiply to give negative 49b squared, one of them will need to be positive and the other negative. And this is our fully factorised difference of 2 squares. Thank you so much for watching this Now Maths video on factorising the difference of 2 squares. If this is a topic you need more help on, please be sure to check out our in-depth video linked below. See you next time.